The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and software test professionals, we welcome everyone today to this webinar on test estimation. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and a leader in quality hardware and software testing. RBCS has offices in the United States and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients. We help them get quality software and hardware products to market on time and with a measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. We have helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to their customers. I am the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, Managing the Testing Process, and Fundamentos de Pruebas de Software, the first book on the ISTQB certification in Spanish and the first book in any language aligned with the 2011 Foundation syllabus. I have a degree in computer science and engineering from UCLA, and I'm also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. RBCS is presenting this webinar in partnership with software test professionals. In addition to our ongoing collaboration on webinars and training, I will be the opening keynote speaker at the Software Test Professionals Fall Conference on October 25th in Dallas, Texas. Hope to see you there. In addition, if you haven't visited their association website, make sure you check it out as well. That's www.softwaretestpro.com. Attendance at today's webinar does earn PMI PDUs. I would like to thank Ken Young for his help in reviewing the material for PDU status. Before we start the presentation, the usual housekeeping notes. If you have any questions during the course of the webinar, submit them at any time. You don't have to wait until the very end. Your webinar interface has a question capability, and you can submit them as they occur to you, and I'll get to them when we get to the Q&A session at the end. You do not need to ask for presentation copies. The presentation is already on the web. It's at rbcs-us.com. Select the Resources tab, sort of in the upper middle, and that will cause a menu to drop down, and you'll see Library Selection, and you go to Basic Library, and you will find the slides there in PDF formats. Should have no difficulty finding them, though you might have to navigate a bit on the page. There's quite a bit of material on that page. There is also no need to ask how to register for the free e-learning. Simply by attending this webinar, you are automatically registered. You check your email over the next couple days and watch the spam filter to make sure that that notification doesn't get lost. You do have a limited time to respond if you are the winner. If you're having any problems with either the audio or visual components of this webinar, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online, or if you're dealing with an unreliable connection, go ahead and download the slides from the basic library and then use the telephone to connect rather than voice over IP. Though typically we don't tend to have a lot of problems with that, and the most common problem that people have is that corporate firewalls prevent them from accessing the webinar, and once that firewall issue is resolved, then they're able to get to it. It works just fine. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we're a not-just-for-profit company. So today's presentation is on test estimation. How many testers do you need? How many tests? How many bugs? How long will the testing take? So these are all challenging questions, and today I'm going to present some thoughts on how to address them. Okay, so first we've got to kind of take stock of, what are we trying to accomplish with estimation anyway? Well, what we're going to try to do is we're going to come up with a good guess, if you will, scientifically based guess of the resources required, people, hardware, software, network infrastructure, etc., and the time that will be required, the duration. And then that has to be adapted typically to constraints and realities of the project. So what would make an estimate a good one? Well, it should accurately predict and guide the project's future. I mean, anybody can estimate if you don't care whether it even remotely comes true. Pull random numbers out of the air and say, oh, well, this many people and this many tests and this much hardware and this many days and so forth. But if you do that, you have a very limited likelihood that that's going to come true, which will affect your credibility on future estimating endeavors. And in addition, of course, if the estimate is not realistic, you can't use it to guide the project. What I mean by that is you cannot track against your estimate and say, okay, well, here's what we planned and here's what's actually happening, and so what's the reason for the discrepancy? Was the estimate bad, or was there some unforeseen development that's come up that's made the at the time valid estimate now invalid? And that certainly happens as well. So prediction and guidance is something that we want. We want the estimate to be realistic. So it should be a complete, based on a complete understanding of all the tasks that are to be done, with each task accurately estimated. As likely to be done early as late is one way to think of accurate estimation, is if for any task the chances are the same that it will be completed in less time and with fewer resources as the chances are that it take more time and require more resources. And in addition, all the risks should be understood and mitigation in place. Now, when I say risks here, I'm not talking about quality risks. I'm talking about project risks, things that could go wrong that would cause the estimate to not be fulfilled. And to the extent that you have identified, understood, hey, these are the things that could happen that would make this estimate not come true, then you want to put some sort of mitigation or contingency in place that says, okay, here's what we're going to do to try to avoid this problem. An estimate also needs to be actionable. At the end of the estimation, once we've reached agreement, then we should have clear ownership of the various tasks. It's not something to be done. There are specific things, and the person who will do them is known. And not just known, but also committed, that the individual contributors who are going to do the work all have an understanding of that they're signed up for this task. This task is to start at this time and continue to that time and so forth. It's not something that's going to be a surprise to them to find out. All necessary resources have been identified and assigned, and to the extent that those resources are not currently available, a plan is in place to secure those resources in a timely fashion, ideally avoiding situations where a resource arrives or is made available only moments before it needs to be used. That sometimes happens with very expensive resources that tend to be very heavily booked. For example, mainframe time. But that is, of course, a source of risk. And many of you who have been in the test management business for some length of time can probably recall, as I can, situations where relatively minor pieces of equipment or infrastructure or something, in one case that I can think of, literally a $5 cable, led to massive delays in testing because while we had requested the cable, the person in charge of procuring the resources for testing had not followed up on that. So that's something else. We want to make sure we've identified all the resources and we've got we either have them or we are going to get them, and we have confidence that they will arrive on time. Also, known dependencies. To the extent that we have dependencies, and we tend to have a lot of dependencies in testing, that those dependencies have been identified, and that the owners of the tasks associated with those dependencies also understand that any delay on their part will result in a delay corresponding, or perhaps even more serious delay in the testing area. And I'm sure that those of you who've been as test managers for a while, again, can think back to instances where testable code wasn't delivered, or requirements weren't delivered, or some piece of equipment wasn't handed over as planned, and any number of these things can be create a problem. So you see that when I'm talking about estimation, I'm really talking fairly broadly about a comprehensive understanding of all of the activities and the relationships between those activities that go into a successful testing effort. So it's not simply pulling a number out of the air, pulling some numbers out of the air, or drawing a pretty Gantt chart with Microsoft Project, but it's about really obtaining a deep understanding of what do we need to do to get this testing done. Now, overall process for estimation, things that we need to do, ask the experts and ask owners. What I mean by that is, when we're thinking about what needs to be done and how long it will take and what resources are required, should be people who have done it before available to us that we can ask. We also want to ask the owners, the people who are going to do the work. Again, this is part of establishing the commitment that I talked about before. People who are not consulted in the formulation of a plan, yet are expected to carry out the work in that plan, are often less supportive of that plan and its success than if they are involved. If somebody told you, I can do that task in 3 days, and then they start to do it and they find, uh-oh, this is harder than I thought, many people will have the common decency is too strong a term, but will have the level of personal integrity or desire to be good to their word that would say, if I have to work some extra hours to make up for this, I'll do that, because I said that it was going to take this long. I said I'd get it done, and so I'm going to. Of course, as a manager, you should try to inspire that level of personal integrity and commitment in your team. If people are simply told, here's the task, and you have 3 days to do it, and they think at the time, and maybe even say, that's ridiculous, there's no way it's going to be done in 3 days, then when they turn out to be right, they're not going to feel like they should necessarily have to work harder. Now, of course, you can use negative consequences to try to force people to do that, but that's really not leadership at any stretch of the imagination. That's bordering on bullying in some way of, I made a mistake and I expect you to clean up my mess is sort of what that comes across as. And if you expect to inspire loyalty as a manager, that certainly will not do the trick. You also want to look at metrics and industry averages. When you come up with your estimate, benchmark that against the industry averages. Capers-Jones's book, Estimating Software Costs, is a great source of all sorts of industry average numbers that you can use to benchmark yourself and see where you stand in terms of industry average. Are we more people or less people, more effort, less efforts, more test cases, less test cases? And those are things that are worth looking at. More valuable than that, though, would be metrics from past projects that you have carried out. Those are really very valuable sources, and we'll see some examples of that. Now, the third piece here is actually where I want to start, because it's one of the harder pieces, and it's one of the places where we as test managers often fall down, which is carrying out proper negotiation with managers and other stakeholders once we've come up with an estimate to try to adjust that estimate, fit that estimate within project realities. So, pardon me. The important thing to understand here is that managers and other project stakeholders bring to the test estimation process, and their part in approving the estimate, basically, a certain mindset, certain expectations, and there are those can be categorized into 4 main types, 3 of which are perfectly fine expectations and can be managed within, 1 of which is impossible. So the first expectation is that an expectation that you and your team will cover the test basis completely, regardless of any cost or schedule implications. Now, when I say cover the test basis is just whatever your tests are based on. So if you're doing risk-based testing, that you're going to cover all the risks that were identified to some extent, whatever completely would mean. If you're also doing requirements-based testing, it would mean that every requirement has been tested to the extent appropriate, and again, that might tie into your risk analysis. If you're doing regression testing, then they might expect, well, that every major feature has been regression tested, and it costs what it costs, and it takes as long as it takes to do that. Right? Quality is job 1, basically. This expectation, and if everybody has this expectation, then great. You're as long as you have the talent to produce an accurate estimate, you should have very little trouble getting support for that estimate. Now, the next expectation is cover the test basis as completely as possible within schedule constraints, but money is basically not an issue. You can get you as much money as you need, but it has to be done by a particular date. And this also, again, this is a reasonable set of expectations to operate within, to the extent that you can make things go faster by throwing more resources at them, then they can be done. To the extent that things simply take too long, then they will not be done, and everybody will understand that. And again, if you can put together realistic estimates, you can say, well, these things simply cannot be done because no amount of money is going to allow us to have them done in this time, but these are all the things that we're going to do. And the third assumption is cover the test basis as completely as possible within schedule and cost constraints. So in other words, do as much testing as you can, but the schedule can't go out past this particular date, and you can't have more than this amount of money. Now, any one of these 3 expectations, perfectly fine. You can live within those as a test manager, provided that all of the other managers and stakeholders on the project, at least the key stakeholders, share a single one of these expectations. If they're all over the map, and some people are saying you got to cover the test basis completely regardless of cost and schedule implications, and other people are saying no, you got to stay within the schedule and cost constraints, you have to identify the mismatch in expectations right up front, and then get those stakeholders to work that out, to work out that disagreement. And because you don't want the fact that people have different expectations of what you're going to do to end up in making you look bad. Because if people do hold different expectations across this first 3, and again, they're all realistic expectations, but only one of them can be the reality on any given project. So make sure that that's clarified. Have that conversation. Now, the 4th expectation here is that I call breaking the iron triangle. And basically, they're saying we're going to constrain you in terms of here are the features you're going to test. Okay, here's the schedule you got to hit. Here's the budget. Here's how much money you can have. And oh, by the way, you've got to test completely. We want the test basis covered completely, and we're not interested in any excuses. Now, here's the iron box and triangle here, just to make sure that I'm clear what I'm saying. Let's get Mr. Highlighter here. So, I mean, fairly typically, a project starts and we define the features, right? When I say we, I'm talking about the project stakeholders, project team, customers, users, whoever. working with business analysts, requirements engineers. There's some set of features, because otherwise, where's the project, right? We're trying to create something, and there must be some set of wants and desires that people have that, we define those. Okay, great, that's what we want. Now, what often happens next is, okay, yes, set features, probably some flexibility early on, but, set features. And then the next question is, well, when do you want it? Right? And now people say, oh, well, we need it done by this date. That's typically the way it goes. And the next thing then is people say, okay, well, we've got schedule defined. What's our budget? And that's typically the next thing. How much money can we get for this, or can we have for this? Now, at that point, within the capabilities of the software process as it exists, the quality is going to be whatever joins these two ends. Okay? And then you see that here. And then the question there is, well, is that an acceptable level of quality? Yes or no? And it either is or it is not. Now, when I say accept quality, what I'm talking about here, I'm talking about the totality of quality related activities that are going to be carried out on the project. The testing, the reviews, unit tests by the developers, all that whole totality. Now you could say, well, yeah, there are various ways we can change the process such that within that same set of constraints, schedule, cost, and feature constraints, we can achieve a higher level of quality. Yes, indeed, that is true. But what we're talking about here is process estimation. We're not talking or project estimation, not process improvement. And during the estimation process, one should always be extremely skeptical of any assertions that, well, this time we're going to do it right. This time our process is going to change, and we're not, just because you found 1,000 bugs in a project like this one last time, and this time you're only going to find 100. Right, sure. That's just not the way that works. I mean, process improvement is not something where during the estimation process that somebody just waves a magic wand in the air, sprinkles quality pixie dust all over everybody's head, and then all of a sudden everybody does their work perfectly. You should expect that the process has certain capabilities, and that's what you're going to get. So now, if the level of quality is not acceptable, then we can iterate this process. And what I mean by iterate is we can cut features, can expand schedule, we can expand cost, and then that's going to produce a different quality equation, and that might or might not be acceptable. And again, we could go through this iteration a few times. I've certainly been involved in estimation where there were a good 3 or 4 iterations about what was in scope for testing and what the features of the product were, and the schedule and budget and all that happy stuff. So be ready to do that. I think all too often what happens is that test managers allow themselves to be beaten down during the negotiation process, and then they finally go, okay, well, fine, I'll just do it, whatever you say, boss. And they sign up for an unrealistic schedule, and I don't want to make it sound as if people are really super cynical, but I think part of that is what's going on subconsciously is, if I'm being forced to give an unrealistic schedule, I bet everybody else on this project is too, which means by the time test execution starts, everything will have blown up, and it'll be impossible to hold anybody accountable for missing the schedule. But unfortunately, even if you are thinking of that cynically, it probably will not work out for you that way, because the time when the schedule is most likely to blow up, the unreality of what was planned is going to surface is typically during test execution. And we see this on sequential life cycle models. We see this on waterfall and V-model type of life cycles. We see it on Agile. We see it in iterative, that the overcommitment, under-resourcing on projects is most likely to come to light during test execution and produce problems for the test manager disproportionately. And the reason why I discussed in a previous webinar on testing psychology, which you can go listen to the recorded version of that if you're curious. But the short version is that you know, you're pretty much, if you're the one, if the spotlight's on you and the project goes south, people are going to say, well, it must be the testing went badly. So really, you want to avoid signing up for a schedule that you know can't happen. Okay, now part of estimating in a number of situations can involve putting together a work breakdown structure using some tool like Microsoft Project, something like that. Now, this is not a webinar on how to use Microsoft Project. There's plenty of books and tutorials and so forth on work breakdown structures, but for testing per se, you know, when you create a work breakdown structure, what you have is a hierarchical decomposition of the overall testing process down into its constituent sub-processes and then activities and tasks. And so one of the ways I like to think of this is you can say, well, you know, what kind of stages are we going to go through? Well, there's a planning stage, there's a staffing, if applicable, there's test environment, acquisition and configuration, there's development of the tests. By this I mean design and implementation of the tests and test cases and test data, test environments, so forth, everything you need to run the test. And then there's test execution and the reporting of the results during test execution and so forth. So then within each of those stages, you can break down to actually discrete tasks. Tasks typically should be short, 1 or 2 days. They should have a single owner. So you sometimes in project management parlance, you'll hear this phrase inch pebbles as contrasted to milestones. Basically, what that means is if you make this fine-grained, your work breakdown structure, you will be able to measure against it as you go along track. Now, I don't recommend actually doing that, using a work breakdown structure to track the execution part. Usually the way I'll do that is through some sort of diagrammatic view, which I'll show you a little later, of what the test execution periods look like in terms of the effort, and then they use spreadsheets or some other test case tracking mechanism to keep track of which tests have been run. What I've found is work breakdown structures are too coarse-grained to serve as good tracking mechanisms during test execution. Excuse me. Got a lot of smoke down here in Texas, and it's making pretty much everybody cough. Now, in terms of figuring out what you need to do during planning, staffing, environment acquisition, and development, what you have to do is think about, well, what tests do I need to execute? So assuming that you've done some sort of analysis, like a risk analysis and analysis of your requirements, you should have an overall sense that these are the test suites that I'm going to need to run. And then what you do is work your way backward and say, well, what would I have to develop? You know, for example, you're talking about a performance test suite. What would I have to develop? A performance test environment, some automated scripts. I'd have to acquire a tool. I'd have to acquire a test environment. I need to bring in an outside expert because we don't have expertise in performance testing. I'd even have to write a separate test plan for performance testing. So that's what I mean by working your way backwards. Now, usually what I find is if I'm doing this, I can put together an initial task list, work breakdown structure, and then I'm going to want to get together with the test team and start working with them on both making sure that the list of tasks is complete and also understanding the effort and duration and resources required. Now, there are some fairly standard project management techniques, theoretical, if you will, techniques. One is called the Defect Oracle. And in that, what you would do is gather estimates for each task from each team member. To the extent that every team member agrees on the duration and effort associated with the task, then that's fine. That's your estimate. If there's disagreement, then you ask the high and low estimators to explain their reasoning, and then you re-estimate for that particular task. And if there's still discrepancies, then again you can go through that. You know, is the high estimator why you think it's going to take this long? With low estimator, why do you think it would be that quick? Re-estimate again. And if you still don't get concurrence, then you can use the average. And again, these are hypothetical techniques. The 3-point technique is you have the team estimate the best case, the worst case, and the expected case for each task. Use the expected case as your estimate, and then you look at the variance between the best case and the worst case, because that'll allow you to say, you know, for this task, we've got pretty big range of possible effort or duration numbers that could come in based on a number of variables. So this is a high-risk task, and you might even put extra risk mitigation in place for those things that people see could very easily take a lot longer than one would expect. Now, those two techniques combined is called the wideband. Now, I find that I typically don't carry these out in the sort of textbook fashion. It's more a matter of getting people together, going through the estimate, discussing how long things are going to take, putting those numbers up there. People disagree. We discuss a little bit. If it comes an unbridgeable gap, I just pick the number that I feel most comfortable with and say, well, let's go with this, and make sure that part of this conversation is, you know, what's the best case, what's the worst case, what's the expected case, what can we do to head off the worst case scenarios. So I think these techniques can be applied in a way that's more practical than you read about them in textbooks, and they sound very, very formalized. At least in terms of, you know, sitting around with a test team of 10 or 5 people, the formality can be reduced. You can also look at historical data, as I said, industry averages and rules of thumb as you're going through this process. Expert advice, if there are people who've done it before and no longer in the team, you can ask them. So there's a number of things that you can incorporate into this. Now, it's very important that during this process you understand dependencies. So if you're working on a small project, you can see your complete list of tasks on the screen at once. It can be pretty simple to work through this process on the screen on your computer, and put a projector up, project it on a wall, a whiteboard, or a screen. For larger projects, we got a large number of tasks. Can't really see them all on the screen at once, and so it's difficult to get a holistic view of the tasks. So better to put the tasks on index cards or sticky notes, and then use a whiteboard where the whiteboard is broken down by weeks, or, you know, whatever is appropriate in the time scale of your project. And the way that this works is you first identify tasks that have no predecessors. So those can start as soon as the resources are available. Then you identify tasks that are dependent only on a task that was previously identified. In this case, the ones with no predecessors at first. Okay, draw a line to connect those if you're using the whiteboard, using a marker, or if you're using Microsoft Project, then you just add that as a dependency. And then you look at the tasks that you haven't identified the dependencies for yet, and say, okay, which ones only have dependencies on previously identified tasks, set those, and you just repeat that process until you've gone through all the tasks and identified all their dependencies. Now, at that point, you can, if it's in Microsoft Project, you can see this immediately, or whatever your project management tool is. If not, you get it into a project management tool, and you can see the critical path. Now, critical path is a sequence of dependent tasks where any one of them slips, and it will cause all of the subsequent ones to slip due to the dependencies between them. And the end date of the project is dependent on one or more of the tasks that are in the critical path, which means that the critical path, that the end date slips. So that's when somebody talks about critical path, it's a task that if that task takes longer than expected, it would be necessary to make up the corresponding lost time on some subsequent task on the critical path, or else the project would be delayed. You can also have near critical path, which you need to look at too, which is where there is some slack. Some of the tasks can slip by 1 or 2 days, but if they slip by more than that, then they will end up colliding with a task that is on the critical path, and then they'll basically be on the critical path. So you want to understand those, because the tasks that are on the critical path or the near critical path are the ones that pose the highest risk and must be treated accordingly. You want to put mitigation and contingency. Typically, look at things that would potentially affect a phase entry or exit criteria, your ability to start or stop a particular phase or level of testing. In test execution, you need to look at how many test passes, how many releases, how many cycles of testing are going to occur. And again, this is something I typically do pictorially, as I'll show you in a minute. And make sure that you identify not only internal dependencies, those within the test team, but also external dependencies. Those are a very frequent cause of delay. You need to, in your planning process, make sure that those external dependencies are clearly communicated to the people upon whom those dependencies rely, and get their commitment to support your schedule. I've certainly had plenty of experience and seen plenty of clients, and have plenty of clients tell me about experiences where everything went just fine until 2 or 3 external dependencies broke down, and that just torpedoed the entire test project. Now, the next thing we need to think about here is resources. So we got people, and these people can be test engineers, skilled testers, skilled and experienced testers. They can be test technicians, low-level people brought in to run tests that are defined by others. They could be contractors to some extent. They could be outside resources using a testing service provider. Now, an important thing to remember is that less skilled people to do any task, not only do they not do it as well, it increases the effort and duration. Now, this has an important implication, because if the schedule was put together, when somebody says that task takes 2 days, what they mean is that task would take me 2 days. If the work is to be done by somebody other than the person who estimated it, it's very important that you talk to the person and say, well, that might be how long it would take you, but given the level of resource that we're probably going to assign to run this, how long do you think it'll take them? So that's something important to consider as you're going through this process. Another thing, too, is that the people's skill and experience with some task or tool will determine the accuracy of their estimates. So when you're going through the estimation process, if there's nobody who has experience with carrying out that task or using a particular tool, understand that their estimate is likely to be a lot less reliable, a lot less accurate than somebody who's done it a lot. We also have test environments: hardware, software, networking, facilities, internet connectivity, whatever, all the things that make up the environment. You definitely want to make sure that as you're going through and estimating resources, that you're looking at ideally all the resources. Certainly, you don't necessarily have to worry about pencils and pens, but servers, tools, lab space, things that take a long time to get set up for whatever reason, connectivity sometimes in that category. Make sure that you have thought about that, because you find out that you've forgotten something that's really expensive, and then you come back and say, oh, by the way, we need a $50,000 server. People aren't going to be happy. And in terms of tools, make sure that you've thought of those. If there are going to be any custom or open source tools, make sure you've thought through that whole process. If there are going to be commercial off-the-shelf tools, make sure that you've got adequate budget for that. Now, common mistakes that people make here that you really, really want to avoid. One is the assumption that 2 people can get the job done in half the time. This is so famous, a estimation myth, that there's a book about this called The Mythical Man Month by Fred Brooks. It's not only about that, but that's one of the things that it talks about, is that thinking that throwing more people will necessarily accelerate the process. It might or it might not. Do not overload the tools. If you've got license limitations, keep those in mind. Don't overload the test environment. Don't try to run, say, performance testing and functional testing in the same test environment at the same time. Don't try to run automated regression tests and manual functional tests in the same environment at the same time. Those can result in problems, and often have for our clients. Also, make sure that as you identify these environments and tools, that you go back and revisit your schedule and say, have I forgotten any setup tasks that are required for this particular environment? Are there ongoing support tasks that are going to be required for this environment or this tool? Because that's an easy thing to forget. You forget the tasks during the estimation because you didn't realize that you needed that environment. Then you find that you need the environment as you're going through and assigning resources. If you don't go back and assign these setup and support tasks, then you've got problems that will pop up regularly in your test execution and cause delays. Okay, so far we've been discussing things that are pretty much general principles of estimation, project estimation. Now let's get into something that is very much unique to testing, and this is the prediction of test execution time, when you're going to be done actually executing the tests. There are two parts to this question. That's the thing that tends to trip people up. There's the obvious part, which is how long would it take to run every planned test once? So we've got to look at things like, what's the total estimated amount of time across each test? How many person hours of tester time are available in a given week? Of those person hours, how much time is spent by the tester actually running tests as opposed to doing other things like filing bug reports and doing confirmation testing and attending meetings and updating test cases and so forth. This is sometimes talked about the time on task, and it's not 100%. That's something that's really important to keep in mind. It can be anywhere from 50 to 75%, depending on who you ask. Johanna Rothman's done some interesting work on this. I'd check her website for thoughts on how much time is typically spent on task by a technical person. So that's part of it, and certainly you have to think about that. But you also have to look at how long is it going to take to find all the important bugs, get fixes to those bugs, and then confirmation test those fixes. This is where people sometimes balk and they say, well, that's not something I can control, so why do I have to do this in my estimate? Well, because your testing won't be done until this has happened, until the important bugs have been found and they have been fixed and you've confirmation tested those. Your testing won't be done. Again, remember, we want an accurate estimate. We want a realistic estimate. It's not realistic to assume that there aren't going to be any bugs. So here you're going to want to have some historical data that you can refer to, and ideally you can put together what's called a defect removal model, which I'll show you in just a minute. It's a fancy name for a relatively simple thing. But let's start with the first part of this. How long is it going to take to run the tests? Well, one of the things that you have to understand how long it's going to take to run the tests is how you're going to run them. What I mean by that is during execution, how much scripted testing is happening, pre-designed tests based on requirements or risks or what have you, automated tests, how much exploratory testing is going to be mixed in with the scripted testing. I typically like to see about 10 to 20% exploratory test effort mixed in with the scripts. And then regression testing. How are you going to go about doing regression testing? Are you going to repeat tests? Will each test be run just once? Is every test going to be repeated if you're going to repeat tests? You're going to rely on an automated tool that does that? If so, how frequently is that run, and where is it run? How is it run? So what I would suggest is to try to come up with a consistent definition of what your test cycles are, which is the number of tests run per build or test release that's delivered to you. And then look for your test passes, which is how long it takes to run each test once. Think about the historical problems that you've had in your organization with buggy deliverables, stuff that is delivered that's untestable, or stuff that's just plain uninstallable. Plan for how you're going to deal with that. Think about the amount of confirmation testing that you might need to do, because you need to set aside time for that. and then you're going to have to check this against your bug prediction. Now that's, I'll talk about bug predicting in a little bit. And here's the thing again to remember: the testers will typically spend less than 100% of their time testing. So as you're going through this process, looking at all the things that have to happen during test execution, and don't just assume, oh well, we've got 4 testers and we've got 160 hours of test cases, so we'll have that done in a week. That's extremely unlikely that would happen. And here's a picture that I find helpful. Now your picture could vary quite a bit depending on your project, but let's say that we're talking about system testing in a sequential life cycle. So your system testing period is going to start when your feature complete. Let me just use the Mr. Magic marker here. So this feature complete release is the first release. The programmers say we're done. All the features are now checked in. So the release engineering team puts together a build, delivers it to you for testing. So that's release number 1. Okay, and then you're going to run a cycle of testing. To me, a cycle of testing is just a collection of test execution activities that occur against a single test release. And in this case, you see we've got some confirmation testing. We've got some scheduled manual and automated test scripts that we're going to run, and we've got some time set aside for exploratory testing. And basically, it's 20% confirmation testing, 60% scheduled manual and automated tests, and 20% exploratory. And they're all the same. See that? They're all the same. Now, they're drawn. It looks like this is Monday and this is Friday, and these are the days in between. Not necessarily. This can be done in a number of ways. So I typically find that when you're doing these weekly releases, development managers really do want you to run your confirmation tests first, so the developers can find out which bugs have actually been fixed. And it's in your best interest to do that too, because you want the programmers to know if they haven't fixed something right away so that they can get back on it. And then here we have that it's taken 2 weeks to run through a pass of testing, and pass again being that we've gotten through all of our planned tests. And that's just one way to organize it. Here you see that we're going to do 3 passes through our tests. We're going to re-execute the tests 3 times based on this plan. Now, what you can draw from just knowing an estimate of how many test cases you've got and how many people you've got, how much time they spend, you draw this picture, but how long it's going to take. Why is it going to be 3 passes instead of 6 or 2? That's again back to this question of how many bugs you're going to find. So we're going to move on to that. How long is it going to take to get the bugs out? Now what you want to do here, I would suggest, is get some historical data and your test cycle model, basically, and then you put together a mathematical model for how many bugs you're going to find. So you can say, use a number of techniques for this, and these are collectively called parametric estimation techniques. Called parametric because you're going to pick some project parameter that you know at the time of execution, or the time of estimation, excuse me, and can plug into a mathematical model and use to predict the number of bugs. So, for example, we could say, historically, we find X number of bugs for every risk item identified in our quality risk analysis, or Y number of bugs for every requirement specification element in the requirement spec. Or if you have lines of code measurements available to you or function points available to you, you can use that. Another technique is to use the number of bugs per developer day. You go back and you look at, okay, on the last project we had say 1,000 bugs, and there were 500 developer days expended on that project, so that's 2 bugs per developer day. Just totally made that number up, by the way. Don't use that as an average. But you see, the idea is to come up with some parameter that will be available to you during estimation, and then and is also available to you for previous projects, for those projects for which you know the number of bugs, and you can come up with this historical average number of bugs that per, again, developer day, or per function point, or per risk item, or per requirement. And notice that this technique can also be used to predict the number of test cases, because you can look at average number of test cases per requirements element, average number of test cases per risk, so it can be used to do that as well. Now, then you need to look at how long it's going to take to find those bugs and how long it will take to fix them. And again, this stuff is beyond your control, but it should, if you've got a consistent team, should be something that you can use historical data to try to predict. And the more data, the better. So here's an example. Simple defect removal model. Basically, what I did is I looked at some projects. I said, okay, for on the bug, using the bugs per developer day model, I came up with average number of bugs per developer day, and then you can plug in, okay, how many developer days are going to be on this project, which you should have available to you, because the development team should have an estimate for their effort at this point too. And then I said, all right, so what percentage of bugs are found in the first cycle, what percentage in the second cycle, what percentage in the third cycle, and so forth, which is what gives you this kind of shape here. Now, how do you know whether it looks like this or some other shape? Well, typically, you've got the bug discovery curve that follows this sort of C shape here. Another one that you might see, not unusual, is an S shape. So you look at your cumulative bug found and fixed curves for past projects and see whether it falls into the C shape or the S shape. So let's assume it's C shape, as you see here. Then excuse me. Then we have to figure out the bug fixing, and again, there are a couple ways to do this that are pretty simple. One is you can look at the number of test releases that typically separate the test release in which the bug was detected and the test release in which the bug was fixed, and create a histogram, and you can see what those percentages are. Like maybe if you got weekly releases, maybe 50% of the bugs are the fixes delivered in the next release, and then 25% in the release after that, and then 15% in the release after that, 10% in the release after that, and then 5% in the release after that, or some kind of simple rule just by doing that histogram, how many intervening releases. And that's what I did here. And then basically you can apply that model to show, well, based on when the bug is found, how many fixes am I going to get? Understanding is you're kind of accumulating, and hence there is something of a lag before it really catches up, as you see here. We get a lagging kind of effect right at this point. It's finally catching up and converging. After basically we stop finding new bugs here. And again, I want to point out this is predictive, right? I mean, it's no. You're probably familiar with these kinds of open and closed curves during test execution, but I'm talking about doing this in a predictive way based on historical data. Now, there's another way that's even simpler to predict the cumulative bugs resolved, which is to look at a metric called closure period. And this is something I've discussed in my books and presentations on metrics and so forth. And, there's examples of it out on the RBCS website of how to calculate it. Basically, closure period is the average time from discovery to resolution, and you can plot that as it changes over the course of the project. The closure period tends to be pretty stable on your project. So if you look at past projects, you say, closure period on average is 10 days or 7 days or whatever it is, right? now average number of days from discovery to resolution. You can do this really simply by just saying, well, the cumulative bugs resolved curve is going to tend to lag the cumulative bugs found curve by the closure period, plus or minus some number of days. So if it's 10 days, you could just say, well, once I've predicted the date on which I will find the last bug, which in this particular case is right here, I'm just going to add 10 days to that, and I'll be done. And you can see that would work pretty closely here too. So that can be a somewhat simpler form of defect removal model. Just looking at the closure period and using the closure period for your estimate of the cumulative bugs resolved number, rather than trying to draw this this graph based on that more complicated prediction. Now, of course, the more complicated prediction is likely to be more accurate, but you have to ask yourself, what's the level of accuracy that I need on this? If it's truly life and death that the thing be done on exactly a particular date, then yeah, you probably need to have this very accurate. The thing that's going to be most determinative, if that's a word, of accuracy in these models is really how good your data is. Is your data accurate? Do you have data from a number of projects? Do you have data from similar projects? Are the projects really truly similar, or are there some significant differences between these projects that you're using for estimation data and your current project? Things like, obviously, different life cycles would completely confound the data. If you're mixing together sequential life cycle data with iterative life cycle data, then don't be surprised when your estimate is completely off. The team's composition changes substantially. That can be another source of problems here. So consider that. Do I have good data, and is the data from similar projects? You might need to separate out some of the data you have and say, I'm not going to use that because it's different. The other thing you want to look at with your data too is if you're coming up with a calculation of, like, let's say you've got 4 or 5 projects, and you go, well, I'm going to look at how many test cases on average we had per risk item if you're doing risk-based testing, or how many test cases per requirements element if you're doing requirements-based testing. You can calculate that average across all those projects, but the other thing that you also want to calculate is the standard deviation, which is the variation between them. If the standard deviation is small from one project to the next, then you can say, oh, well, okay, this is a pretty good estimate. If the standard deviation is large, then the reliability of your estimate is going to be a lot less. And the same with the bugs. If you calculate the average number of bugs per developer day across all projects, and then calculate it across each individual project and check what the standard deviation is across the individual projects. If it's large, then your prediction of bugs will be less accurate. And there's some statistical rules about how you can predict the accuracy of your of an estimate, provide a level of confidence, and also a sort of a plus-minus range of, we think it's going to be within plus or minus some number of weeks or days or whatever, based on statistical calculations. So that's really what you want to do. And that's how a lot of these commercial estimation tools work too. They just have large repositories of historical data and a lot of parameters, and they're going to churn that data out and give you an estimate, some level of confidence based on what you told it. Now, this leads me to the next question that often comes up at this point in the discussion about estimation, which is, well, what if I don't have any historical data? Can I use industry averages? You can. Your level of confidence in those is going to be pretty low. They can be used to establish a range. The problem with industry averages is it brings to mind that joke about the statistician who had his foot in a bucket of boiling water and his other foot in a bucket of ice water, and he said, on average, my feet feel fine. You really don't, you don't know how much stuff has gotten clumped into that average, and how reflective that will be of your situation. But if you don't have any data, of your own, then industry averages is what you're going to get thrown back on. But I'm sure you consult a number of different sources for that, because it's going to be very difficult to know what level of confidence you should have in your estimate if you only use one source. Okay, so concluding thoughts here before we go into the Q&A session. So test estimation, in large part because of all these external dependencies and the difficulty of estimating test execution period based on the fact that you don't control the number of bugs for the most part, does really make it one of the most difficult parts of software estimation. Now, the thing to keep in mind, it's hard, and temptation is often with things that are really hard to say, well, yeah, it'd be nice if I could do that, but that's really hard. You really do need to master this and do this well, because when there is without a good test estimate, you will often find situations where the testing gets truncated by schedule realities. We've seen this over and over again with clients. So, if we want to avoid situations where we're systematically and repeatedly under testing, we really do need to master proper test estimation techniques and project estimation techniques and apply those. Now, it is possible. It's hard, but it is quite possible. I've done it. I know a number of managers who do it. If you apply the known project estimation best practices and avail yourself of historical data, you can come up with estimates for effort and duration that are quite accurate. So you should not think this is an unsolvable problem. It certainly is quite solvable. Just hard. All right, so that concludes the presentation. So as usual, I put the advertisement up and undock the question panel here and start working my way through the questions. I see we have a lot of questions already. That's great. Let's see. We had questions about the presentation. Again, that's posted on rbcs-us.com, and then go to the resources panel, the resources tab. This will cause a drop-down menu to come down. Navigate down to library, and then navigate to basic library, and that will get you there. Let's see. Yeah, a lot of questions about the slide deck. Some people reportedly having some difficulty seeing the presentation. If you are still online and you are having difficulty seeing the slides, do let me know. It is possible that your firewall was blocking your access, so I'd like to know about that for those who have that problem. Let's see. So Fahad asks, so we also need to make almost all stakeholders agree on one type of expectation. Now that's in reference to slide 3 here. Yes, and almost all is the right word, Fahal. I mean, you can't. Not everybody involved in the project has got to agree on this, but there are going to be key stakeholders. The business analysts, the development managers, the project managers, the product managers, key stakeholders whose opinion about the success or failure of testing is very important. They all need to hold one of those first 3 expectations and agree that that's the right approach to use for testing. And if anything else is the case, then you're going to have one or more disgruntled stakeholders. They're just going to feel like, hey, that those testers, they didn't do that the right way. They didn't go about the testing the right way. And this can be really shocking. I'll tell you, you might think that there's going to be concurrence, but the odds are the first time you have this conversation with people during a testing estimation process, you will find that people are all over the map, and you will find that you've got a lot of people with that fourth assumption too, which is they've never thought about the fact that the feature schedule and budgets constraints are going to strongly affect how much is going to get tested. Now let's see. I've got a couple questions here from Peggy about not being able to see the presentation. Peggy, if you're still online, please send me an email and ideally a screenshot of the problem that you had, and I will escalate this up to Citrix, because it sounds like you've got some sort of firewall problem or something that prevented you from getting into the presentation, and I don't know why. I do want to clarify, though, that Peggy, you asked the question twice during the presentation. I do not look at the questions during the presentation period. I can't give the presentation and monitor the questions at the same time, so I apologize for that, but please understand that I get to the questions at the end. Avner asks, if the resource assigned to a task is 100% loaded, does his load present a dependency to the subsequent task, or how do you work that out? Yeah, that's absolutely a potential issue. Once you have assigned the resources and you put these into the typical project management tool, it's generally the case that you can go through and look at resource allocation and check to see if there are any places where you've got dramatically over-allocated resources. And also you can look at under-allocated too. You might have testers who are not doing things some of the time, and there might be other tasks that they could be assigned to. So usually a decent project management tool or project estimation tool will allow you to identify over-allocation and under-allocation of resources, and then you can do what's called resource leveling. Now, the thing, some tools include the capability to do resource leveling, but I've never seen that work out real well when it's automated. So usually what I want to do is try to resolve that by hand, and yeah, that basically means that you've created a dependency. If you've got two tasks that both require the same resource, that can't be done at the same time, obviously, because a resource can only be doing one thing or the other, then you can handle that by establishing a dependency between them. A comment from Chuck. Chuck, good to see you. Don't assume two people can get the job done in half the time. Yes, but project managers do this all the time, and it appears to work. How do we overcome this argument besides saying Rex says this doesn't work? Well, you can say Rex says it, or you can say Fred Brooks says it. But and the thing with this is that it works until it doesn't. And here's what I mean by that: is that in a number of situations, it can work or appear to work in the sense that, if you've got a spare resource sitting around who's not doing anything, and the person is perfectly qualified to write test cases, you could assign that person, and sure enough, assuming that the test cases don't have to be written in any particular order, then they get done. But your problem is that when you have sequences of tasks that have dependencies, one has to be done before the next can be started. It simply doesn't matter how many resources you throw at it. It's going to play out in its natural sequence. And that's the thing. You have to, just saying, well, you can't assume that two people can get the job done in half the time as one, as stating that as a hard and fast rule, because sometimes two people can get the job done in half the time as one, and sometimes they can't. And we have to recognize the difference between those situations. Let's see. Phil says, sorry I missed this. Really wanted to be on it. It was advertised correctly as 8 in Europe, but I just realized they're an hour in front of the UK. So, Phil, I guess you're still on. So, yes, there will be a download available. It's going to be posted on the digital library and also on YouTube, so you can catch that. Also, Phil, if you're going to be up, I'm not sure what exact time it is there in the UK. I guess you're saying it started at 7, or maybe, I'm not sure. So this is probably not convenient to you, but there is going to be another session that's at 8:30 Central U.S. time tonight that you could catch if you're going to be up. And so anybody else who's either wants to catch parts that they missed, or if I don't get to your questions, or if there's somebody else you're working with that you think really needs to hear this presentation, then you can have them tune into the 8:30 Central U.S. time presentation. Let's see. A question from Roxanne, who has left. It says, I have to leave the webinar early. Is there a way to get an electronic copy via email? Well, we can't email to people. It's just simply not practical, but we don't need to, because, as I said, it's available via YouTube and on our digital library, but we can't email them. So let's see. We say Rex Srihari here from Johannesburg, South Africa. Should there be any developer versus tester ratio that needs to be considered when we use the cumulative bugs technique to estimate the efforts for test releases? If you have a historical developer to tester ratio for your organization that works pretty well, that can be one of your considerations. I would not recommend using the ones that you find floating around there as putative industry averages. The problem with those is, but basically, people, myself included, have observed variation in tester to developer ratios ranging from, you see, anywhere from 1 to 1, which is what Microsoft claims, 10 testers to 1 developer, which was what was purportedly used by IBM when they developed the space shuttle software, to one tester to every 3 developers, 1 tester to every 5 developers. It's the 1 to 3 to 1 to 5 range seems to be fairly typical, but there's just so many variables that affect whether this is going to work that and what the ratio should be, that it's usually extremely dangerous to use those. But as I said, if you've got one from your own organization which has worked, that's one that you should refer to. So if your estimate comes up with too few testers based on your historical average, or too many testers based on your historical average of tester to developer ratio, then that's certainly something to look at and say, hey, why is that? Let's see. Judy asks, what if you need to provide an estimate very early in a project before you have any requirements or details around the testing? Are there any good techniques available for this absent historical data? Eesh. Well, I was just about to say, reading the first half of your question, Judy, that you could look at historical data and say, well, these are what the ranges are. I mean, absent any historical data, this is very difficult. You can use some industry averages to say, well, this is what industry averages say, but again, there's that caveat that must be heavily emphasized there, which is that there's a lot of variation. You can look up a lot of industry averages, like, for example, Capers Jones's books, and those are great resources, but the thing to remember is that Jones is giving you averages, it's not providing standard deviation, so you don't know how much variation there is in that data. You just have to be very careful to state your assumptions and caveats in these situations, and recognizing that everybody will remember the numbers that you give and no one will remember the caveats. So make sure that you have it all in writing, because it's, time and again I've heard this sad story of somebody who gets cornered by a project manager or somebody who says, hey, just need a quick estimate on how long testing's going to take and how many people you're going to need for this project, and then you get a one-paragraph explanation of the parameters of the project. You give a bunch of caveats about, well, assuming this, and this, could be this or could be that, and then all of a sudden you're confronted with this project plan, and those dates have become carved in stone. It's ridiculous, but it does happen, and it's hard to overcome. So Judy asks, industry averages and Capers-Jones. Basically, what you want to do is a search for Capers-Jones, C-A-P-E-R-S space Jones, on Amazon. And what you'll find is he's got a bunch of books there. He's got a new one that just came out called Economics of Software Quality. And I was a reviewer on that, and that is a fantastic treasure trove of data. Highly recommend. In fact, I just did an interview with Capers earlier this week, or late last, I can't remember which, and that's going to be posted on the digital library where he talks about it. The other classic of his with respect to estimation is, logically enough, called Estimating Software Costs, and that's another one that's just full of good data, and I highly recommend it. Srikanth asks a question related to the one I had just a moment ago. Most of the time, project managers ask for rough estimation to get approval for budget. In this case, how can we provide estimation? Now, as I said, just caveat heavily and look at industry averages and whatever you know. The question, does RBCS have training available in the UK? Yes, we do. If you are interested in that, get in touch with us via email, info@rbcs-us.com. Let's see, any additional input? This is from Alex. Any additional input on creating estimation calculators and getting test leads to use them? Well, Alex, the spreadsheet that I used to generate that graph, this one here, is available as a download either in the basic library or the advanced library. It's a free download. It's a spreadsheet. I think it's named something like estimating bug find and fix.xls or something like that. It's pretty obvious from the name what it is. So you can download that and use that. There's also another estimation. I think it's a spreadsheet that has the word Sumatra in it. It's an Excel spreadsheet for estimating test cases and so forth based on the number of risks and requirements. So those are out on the website for free download. As far as getting people to use them, well, people use things that they find useful, right? So you'd have to convince the test leads that they do need to produce accurate estimates, and they need to spend some time getting these historical data into these calculators so that they can actually get those estimates out of them. No tester or test manager that I know likes being in a situation where test execution is just dragging on, and the schedule's blown, and everybody's looking for scapegoats to beat up for the fact that the schedule's been missed. There's a lot of pain there, and if you can convince these test leads, hey, one way to avoid that pain would be to come up with rational estimates of how long the testing was going to take beforehand, so that people allocated enough time for it. Then that can be a way of appealing to what their problem is. Anything that connects doing something to removing pain is likely to be something people will follow up on. All right, a couple people here, Mercedes and Michael, basically saying, no problem seeing the slides, saw it fine, loved it, very useful, thank you for doing this. You guys are quite welcome, glad to hear that it worked well for most people. I figured it did because we had 400 and some people on the webinar, and generally people aren't going to stick around if the webinar is not working. Steve asks, can you briefly explain the difference between confirmation, scheduled, manual, and automated, and exploratory tests? Yes. Let's go back. That's this graph. Okay, confirmation test is a test we run to confirm that a change has been properly implemented, especially a change to fix a bug. So confirmation test, confirming a bug fix, typically involves going through the steps to reproduce the failure from the bug report possibly rerunning the test or tests that located the bug to begin with, and making sure that the symptom no longer appears. If the symptom does still appear, then typically the bug report should be reopened rather than a new one being opened, because you want to track how frequently the confirmation tests fail, and your reopen rate is how you do that. The scheduled manual and automated tests would be pre-designed manual tests or scripted automated tests that you're going to run. Testers are going to run through the steps, the procedure steps in the automated and the manual test. Excuse me. A tool will be used to run the automated tests, and then exploratory testing would be testing where somebody, typically based on what's called a test charter, which is a general area of testing they want to go after, like printing checks or something, spends anywhere from 60 to 120 minutes exploring that particular feature or area of the product and designing tests on the fly. And typically, I think during test execution, those are the three main test activities that I would want testers engaged in addition to, of course, the writing of bug reports. And then there are other various overheads that are required. Now this is interesting. Somebody said, if we entered a couple minutes late, we didn't get the slides either. There's another guy in the room who had the slides, so I saw everything okay. Another possibility is that you might have entered the evening session by mistake, and that would be kind of odd. But anyway, if anybody else can provide some more corroborative details, that would be great. I'll escalate those up to go to Citrix people. Jennifer asks, you mentioned somebody that had written several papers. I think you mentioned the last name is Rothman. You share the full name again. Yes, that's Johanna Rothman, and she's written some interesting stuff on project management. So yeah, look up her stuff. Diane asks, are there any tools available to help make estimates? Yes, there are some commercial estimation tools, but so those are often too expensive for people, unfortunately. So there are some free spreadsheets available for download, as I mentioned, from the RBCS website that can be helpful to you. You will probably want to get the appropriate book, Critical Testing Processes and Managing the Testing Process being the two that are kind of got the most explanatory material about those spreadsheets. Rakesh said there is no reference on considering test data during estimation. Well, that's true, but that's part of your test development, and you know, on some projects that can be that can be a real issue. I mean, the creation of test data can be a major sub-project all of its own. So if you're working on projects where there's going to be a large volume of test data required, do make sure that you think about that in your estimate. Donald asks, how do you handle scope creep? Okay, that's a good one. What you will probably want to do with respect to scope creep is to look at your historical average number of new and changed requirements per week or per month, and Jones has some, Capers-Jones has some figures on this industry averages if you don't have historical, but again, your historical is better. And you probably want to include that as a parameter in your estimation, right? Because if you estimate based on the number of requirements you have when you start, that could easily result in an underestimate of the total number of test cases because your actual number of requirements is going to be greater. And similarly, of course, there's scope creep. That probably means that there's additional developer days of effort that can be expended, so you could be underestimating the bugs too. So basically, if you suffer from severe scope creep, you'd need to include that in your mathematical model and put it in your spreadsheet, basically. Darminder says, how do you do the complexity estimate of a feature to determine the number of bugs that will be discovered in a feature? I actually have not included that in the simple model that I showed, the one that's here. But you certainly could, in certain types of agile estimation, they have complexity numbers, size/complexity numbers, if you will, on user stories, and that would probably be highly correlative to the number of bugs that you would expect to find. So, and you could also have complexity numbers available in the standard waterfall or V model life cycles. So if you want to have a real fine-grained type of model where you say, okay, I've got 20 features of low complexity, 10 features of medium complexity, 5 features of high complexity, and you can look at on a feature-by-feature basis what's the average number of bugs for a low complexity feature, medium complexity feature, high complexity feature. You could have a fairly fine-grained model, and that would allow you to handle variation in projects that were producing a lot of low complexity features might very well have a fewer number of bugs than projects that had relatively fewer but more high complexity features. Adrian says, we tend to be given the project end date and we have to work backwards from here. Also get the requirements in code late, which requires us to work so much overtime to complete testing. Yeah. Well, okay, so this is the project end date being specified. That's the second assumption that I talked about, which is, cost can be changed, but schedule cannot. Though maybe it's not. Maybe you're constrained heavily on cost too. So yeah, that happens. As far as the requirements and the code showing up late, yep, that happens too. This gets us out of the realm of estimation. I mean, if you're using historical data, you're predicting based on historical data. You're predicting based on that happening to you again. Well, what you need to do is stop throwing yourself under the bus with all the overtime. Basically, this is where risk-based testing comes in. Is you say, look, we're going to do a risk analysis, and we're going to identify things that are the high risk, low risk, medium risk, and so forth, and develop tests based on that. There's a bunch of stuff on the website about risk-based testing. And then when you get in these situations where the testing gets crunched, you just start throwing stuff overboard. Basically, it's stuff that just falls off the plate. People might not like that, but I mean this situation where it's a death march for the last 6 to 10 weeks of a project for the testers because of all this stuff that went wrong upstream is really just not not something that's livable. Let's see, Ivor, how can we estimate a project that uses as yet unproven technology? Yeah, that's a big challenge, Ivor. I've had that come up for me before. You're not going to have historical data, obviously, in these situations, and industry averages aren't going to help you much either because nobody else has done it. You just have to accept the fact that there's going to be a lot of unknowns. Now, the thing that you want to do in these situations is have as many senior people involved in the estimation process as possible, because senior people will be, aware of the risks, aware of the unknowns that are associated with this, as well as being able to sort of draw analogies. Well, this project is kind of like this other project that we did, or this technology is kind of like this other technology. So you really fall back a lot on expert opinion. Kathy says, how do you go about allowing for, she says, quality risks in estimations, like not getting the project at the expected time, unclear requirements, loss of resources, etc.? I think you mean project risks. Quality risks are things that can go wrong that would affect the quality of the product. So they'd be things like the system responds too slowly to user input, or it calculates an incorrect answer, or users find the interface inscrutable or unnavigable. Those are quality risks. What you're describing here are project risks. And yeah, absolutely. I mean, project risks are a big thing that you have to capture in your estimation process, and then in your planning process you want to look at mitigation and contingency options to deal with those. And I'll probably have a webinar here at some point in the future about planning. I spent a lot of time in my book, Managing a Testing Process, discussing things that you need to deal with planning. So, yeah, that your project risks put a lot of the estimate in danger, and so you do have to take those into account, manage them. Let's see. Avner makes a good point here. The problem with twice the people is that what happens if the environment goes down? Now 2 people are sitting on their hands. Yeah, absolutely true. That does indeed happen. That's your project risk is increased by increasing your staff, of course. Okay, well, we have a bunch of questions that I'm afraid I just wasn't able to get to. We have reached the end of our allocated time. I do thank all of you for your great questions. If you have a question that I did not get to and you would like to see a response to it, send it to me via email. Send it to info at rbcs-us.com and put something like a blog question or something like that. And what I will do is I will respond to your questions on the blog over the next few days, particularly once we get the recorded webinar up, because then that way it'll make more sense to people. They can listen to the webinar and then the questions and answers and so forth. So I do thank you all, and again, just if you send me the questions, I will be happy to respond to them. You should be able to copy and paste them out of the questions pane that's, I assume, still open for you, and we'll keep the webinar up here for a minute. To close this session, let me tell you a little bit more about the resources that are available through RBCS. We run these free webinar sessions once a month. Check our website, rbcs-us.com, to sign up. If you want a special webinar presentation for your company only of this webinar or on any other topic related to software testing, send an email to info@rbcs-us.com or contact us via our website. And again, this session will be run at 8:30. The Q&A session for that will probably start around 9:15, 9:20. So if you want to come back on and follow up with your questions, then you can do that too. If you don't already receive our regular free newsletter, sign up at rbcs-us.com. This will get you valuable discounts on consulting and training services, and you'll also get a regular newsletter with a featured article, software testing and quality, and news about what RBCS and its partners are doing. You can follow us on Twitter. We're at RBCS. We're also on Facebook, facebook.com/pages/RBCS-INC. Check your email over the next couple days. You might be the lucky winner of a free e-learning course. You're registered for that in a random drawing that will happen tomorrow simply by attending this. Again, check out my blog. That's rbcs-us.com/blog. Post comments on the postings there, or email me at info@rbcs-us.com if there's anything you want to discuss, including, as I said, follow-up questions. You can check out our digital library. It has recordings of these webinars, podcasts, and videos. You can subscribe to the podcast via iTunes by entering RBCS podcast into the search string, or you can see the videos and recorded podcasts by subscribing to the RBCS channel on YouTube. We offer these free resources as a service to the software testing community, because at RBCS we're a not-just-for-profit company. This concludes the webinar. I would like to thank everyone for joining us today.